If you've been following along this whole set of videos, you know we went through a lot of work already on quadratics. We first started with quadratic expressions, we went on to quadratic equations, we solved by the square root property, we solved by completing the square, we solved with the quadratic formula. We looked to see how the b squared minus 4ac part of the quadratic formula, which is called the discriminant, helped us to solve equations. And then we just looked at a whole bunch of examples, including some that produced imaginary solutions. Those were all quadratic equations. We had one side set equal to the other side. But what happens when instead of being equal to, it's greater than or less than? Well, in that case, what we have is a quadratic inequality. Just like we had inequalities for lines, we can have inequalities for quadratics. So instead of an equal sign, there's either a greater than or less than, or it could be greater than or equal to, less than or equal to, which means your answers are going to be an interval. Things like negative infinity to 2, or 7 to 23, something like that, right? An interval of values rather than just one or two specific answers. So what you're going to have to do is test points to see if they work. So how does a quadratic inequality go? Suppose I asked you to solve x squared minus 3x minus 10 is less than 0. First thing is we need our boundaries. So suppose this were x squared minus 3x minus 10 is equal to 0. Well, we would factor this, right? This one factors nicely. If they don't factor, you can always use the quadratic formula, completing the square, etc. Factors of negative 10 that add up to negative 3. Let's go with negative 5 and positive 2. Square it back, you get x squared minus 3x minus 10. So my two boundaries are x equals 5 and x equals negative 2. I'm going to treat these as if they're on a number line, because they are. It's the x-axis. X equals negative 2 is down here. X equals positive 5 is over there. Now I need to pick a value to the left of negative 2, between negative 2 and positive 5, and to the right of positive 5. If I pick a value, put it into the inequality, and it's positive, I'm going to put a plus sign. If it's negative, I'm going to put a minus sign. So let's try negative 3. Now, you could put this into either the factored form or the unfactored form, but look at the factored form. The factored form is x minus 5, x plus 2. If I put in x equals negative 3, negative 3 minus 5 is negative 8. That's negative. Negative 3 plus 2 is negative 1. That's negative. A negative times a negative is a positive. So to the left of negative 2, that function is positive. Put in x equals 0. 0 minus 5 is negative. 0 plus 2 is positive. Negative times a positive is a negative. And then at 5, if I put in 5 minus 5, I get 0, so that's not going to work. Let's pick a number to the right of 5. Let's say 6. 6 minus 5 is 1. That's positive. 6 plus 2 is 8. That's positive. Positive times a positive is a positive. Go back to my original question. My original question said x squared minus 3x minus 10 is less than 0. So where are the ones that are less than 0? Right here. In other words, the values between negative 2 and positive 5. So my answer is that interval, all the values that are greater than negative 2 and less than 5. Notice I didn't include the negative 2 and I didn't include the 5 because this question was strictly less than. It didn't say less than or equal to, it said less than. What follows on the PowerPoint is just me explaining the whole thing, right? We put the boundaries, we set them up on a number line, we graphed it and got the answer. All right. This one says solve, answer with interval notation. So x squared plus 13x plus 42 is greater than 0. First thing I'm going to have to do is factor this. I'm assuming it can be factored because I looked at the 42 and I saw a 7 and a 6, and I said 7 plus 6 is 13, 7 times 6 is 42. It's my lucky day. All right, so my two roots are x equals negative 7 and x equals negative 6. That would happen if I set each one equal to 0. That's what I would get. Well, those two values are awful close to each other, right? Remember on a number line, negative 7 comes to the left of negative 6, but still, they're pretty close. So we got to pick a value in each region. Let's choose one over here, let's pick 0, right? 0 is bigger than negative 6. If I put a 0 in for x, I get positive 7 times positive 6, so it's positive. If I picked a value between negative 7 and negative 6, let's say I pick negative 6.5 because there's no integers between negative 7 and negative 6, so let's say I pick negative 6.5. If the first term is x plus 7, and I put in a negative 6.5, 7 minus 6.5 is still positive. Over here, if I have an x plus 6, negative 6.5 plus 6 is negative. So positive times a negative is a negative. If I put in a number, let's be silly, negative 300. Put a negative 300 in for both of them, you'll get a negative for each, which is a positive. Now the question said, where is this greater than 0? Well, that happens here, and it also happens here. So let's remember how I write this. My answer is that it goes as far to the left as possible, up to negative 7, and then stops, and then picks up again at negative 6, and goes on forever. Another way to think about this is what would happen if I graph this parabola. If this were a parabola and I graphed it, it's a parabola that opens upward, right? I know that because there's a positive 1 before that x squared. So the graph is coming down like this, and then up on the other side. So it's above the x-axis here, and it's above the x-axis here, and it's below the x-axis between negative 7 and negative 6. So you can also use the direction of the graph. The parabola opens upward. Okay, so it's going to be above the axis, below the axis, and then above the axis. All right, let's take a look at number 2 and number 3. For number 2, does that factor? We could try it, right? We could try with the AC method, 4x squared plus 7x minus 2. So let's try 4x squared plus 7x minus 2. Let's see if we can factor that to find the boundaries. All right, so I could try a 2x minus 2 and a 2x plus 1, but that doesn't give me enough to hit that 7 in the middle. So maybe instead of a 2x, one of them should have a 4x. So maybe I'll make this an x minus 2 and make this a 4x plus 1. Let's see if that works. Now you could do this by the AC method also. So I get a 4x squared plus x minus 8x. Okay, that's right, but with the reverse signs. Okay, so let's make that a plus and make that a minus. Now we get a 4x squared minus x plus 8x is plus 7x. 2 times negative 1 is negative 2. So you could have factored that by the AC method. I decided to do it by guess and check. When we set each of these things equal to 0, we get x equals negative 2 over here. Here when we set 4x minus 1 equal to 0, if I add a 1 to both sides, I get 4x equals 1, divide by 4, x equals a quarter. All right, so let's graph this on our number line. Let's put the numbers in the right spot. So let's put the negative 2 over here. 0 is somewhere in the middle here. And then a positive 1/4 is just to the right of 0. I need to pick values to test. So let's pick the 0, right? Because that's between negative 2 and a quarter. If I put in x equals 0, 0 plus 2 is a positive. 0 minus 1 is a negative, so positive times a negative is a negative. If I put in a number like negative 3, that gives me a negative. 4 times negative 3 is negative 12. Minus 1 is still a negative, so that gives me a positive. And if you think about what the graph is doing, right, it's a graph that opens upwards, so it's coming down and then back up again. If it's positive here and negative here, it's positive here. Now, what did the original question ask me to do? It said less than or equal to 0. So less than or equal to 0 is this piece in the middle between negative 2 and positive 1/4. Except because of the equal, I'm going to include the endpoint. So between negative 2 and positive 1/4, including both endpoints. Okay, so that's when we have to check the inequality to see if it's less than or equal to. If it's equal to, we got to include those endpoints. All right, what's the third one there? X squared minus 12x is greater than or equal to negative 36. Let's set this up and see if we can find boundaries, and then see if we can find our interval. X squared minus 12x plus 36 equals 0. Right, I'll move the 36 over to the other side. How does this factor? Factors of 36 add up to negative 12. So x minus 6, x minus 6. Hey, it's the same factor twice, which means that x minus 6 squared is greater than or equal to 0. One boundary point here, x equals 6. So when I set up my little number line, what if I test a point to the left of 6? Let's say I pick 0. I'm going to get 0 minus 6, 0 minus 6. So negative 6 times negative 6 is positive 36. Okay. Pick a point to the right of 6. Let's say 7. 7 minus 6 is 1. 7 minus 6 is 1. 1 times 1 is 1. Oh, that's positive also. Isn't this interesting? Now, before we answer the question, we have to look at that sign. It says greater than or equal to. Greater than or equal to means that there's actually no break here. Because look, every value I pick is either greater than 0 or at this one specific point here, 6 minus 6 is equal to 0. So that statement is true from negative infinity to infinity. Every possible value of that function is either greater than 0 or equal to 0. If this was strictly greater than, then I would separate it in the middle. I would go from negative infinity to 6, and then from 6 to infinity, because technically at that one point, it wouldn't be equal to 0. But here it is. So every single value of x will make that statement true. All right, for number 4, I'm going to skip that one, but that one's one we have to solve by the quadratic formula and then test points on either side. So I said approximate solutions to the nearest tenth because it's something you're going to have to use the quadratic formula for, or you could work through that one by completing the square as well. Let's take a look at number 5. It's the last one in the section. Total profit for a company producing X thousand units. Units of what? Be creative. Widgets, refrigerators, speakers, cars, something, is given by that profit function. Find the values of x for which the company makes a profit. So making a profit means that your profit is greater than 0, right? If your profit is equal to 0, you made no profit. If your profit is negative, you're losing money. That ain't good either. So you want that profit to be greater than 0. So our profit function was negative 3x squared plus 39x minus 66, and you would like that to be greater than 0. Now, I can see that this whole thing is divisible by 3. In fact, this thing is divisible by negative 3, which might make our factoring easier, but we just have to be careful of one thing. And that is, if I divide both sides by a negative, it flips my sign, my inequality sign. So carry it through, I get x squared minus 39 divided by 3 is 13, plus 22 is now less than 0. Factors of 22 that add up to 13 has got to be 11 and 2. Both negative, x minus 11, x minus 2. Now you realize we're working off this equation that's less than 0. So when I write my little number line here I get x equals 11. Okay, so that goes over here. Here I get x equals 2. That goes over there. Let's test the point. Let's test 0. If I put in x equals 0, I get negative 11 times negative 2. The number doesn't matter, it's the sign that matters. So a negative times a negative is a positive. Let's test the value between 2 and 11. Let's pick 5. 5 minus 11 is a negative number. 5 minus 2 is a positive number. A negative times a positive is a negative. And then for the third one, pick 20. Definitely bigger than 11. 20 minus 11 is positive. 20 minus 2 is positive. Positive times a positive is a positive. So we were told to pick the values that made it less than 0. So here are the values that make it less than 0. The values between 2 and 11. Let's go back to the context of the problem. We said the values between 2 and 11 will work. What is x? X 1,000 units. So they should make more than 2,000 units. And they should make less than 11,000 units. If they make that number of units in between there, then they'll make a profit. If you start making too many units, then you got nowhere to store them, or nobody wants to buy that many and you end up making a whole bunch of stuff that nobody buys and it just sits around in your warehouse. If you don't make enough, then you don't have enough to cover your costs. In between that 2,000 and 11,000, that will be where the company makes a profit. So we do use these types of inequality problems to solve real-life applications, and that's one of them. Any kind of profit or loss functions will be done this way.